So now we need to find all of the zeros of this g function. So setting it equal to 0. Since it's x to the 4th, it's possible that there's as many as 4 zeros that we need to find. And if there are rational zeros, we get that from looking at all the factors of this and all of the factors of this leading coefficient, which is a 1, and divide them. So a 2 divided by a 1 is a possibility, and I'm going to use the graphing calculator. X to the 4th minus 5x to the 3rd, I've got it typed in, and then take a look at the function and see if 2 actually is a root, and it looks like it's possible. So trace and put in a 2, and the answer is yes, that is one of the zeros. So using the factors of this, the factors of this, we got x equals 2 is a root or a 0 and an x-intercept. And that means that this 2, when we use synthetic division, will divide evenly into this polynomial, giving us a remainder of 0. So divide the 2 synthetically into that original function using the coefficients. And we start by carrying down this 1 and then multiply and add. So multiply down and then add up. And I'm confident that the remainder is going to be 0 at the end, that this will divide evenly. So we've got a 2 added to a negative 5 is negative 3. We've got a negative 6 added to 7.5 is a 1.5, or 3 halves. Multiplying these two is going to be, well, the 2's are going to cancel, it's going to leave a positive 3. Take that positive 3 and subtract 2 is a 1, and then 2 multiplied with this and added to the negative 2, sure enough, gives us 0. Now this is going to be a polynomial function x cubed, negative x squared, an x term, a constant, and a remainder of 0. Well, if we take a closer look at the graph at x equals 2, so let me zoom into that area, zoom in to where x is equal to 2. And the function goes above the x-axis here and then makes a U-shape, a small U-shape right at x equals 2. Or if I zoom in even more, it basically bounces off the x-axis. It doesn't go through the x-axis. Well, in this little area, if you look at this shape, it looks like a parabola. In fact, it looks like the parabola y equals x minus 2 squared, so that it's a parabola facing up because of y equals x squared, but it's been shifted over to 2. So just in that area, it looks like a parabola moved over to x equals 2. Well, that means that when I set it equal to 0, x minus 2 times x minus 2 means that there's actually 2 answers that give me x equal 2. So they're not 2 different points on the graph, but these 2 different factors say that 2 is a root twice. So it's called a double root. That means that this polynomial can also be divided by 2 a second time. So I can stack the synthetic divisions on top of each other and say divide by 2 again, and the remainder should be 0. So let's try it. Carry down the 1, multiply these two, it's going to be a 2, added to that, negative 1. Multiply these two is going to be a negative 2, added to this. Well, this is a 1.5, a negative 2, and a 1.5 is going to be a negative 0.5 or negative 1/2. And then multiply these two, and the 2's will cancel, leaving only a negative 1. Take that negative 1 and add it up there. Sure enough, the remainder is 0. So we've got that x equals 2 is actually a double root. It shows up twice. So we started with x to the 4th, we divided out one of the x's, we divide out another one, so we're now down to x squared. So that means the resulting polynomial is x squared minus x minus 1/2 is equal to 0. Now that we have a quadratic, we can use the quadratic formula. I think rather than using fractions, what I'm going to do is multiply everything by a 2 and clear the fractions. So 2x squared minus 2x minus 1 is still equal to 0. And then the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times the a and times the c. The whole thing is divided by 2 times a. So x is equal to a 2 plus or minus the square root. The whole thing is divided by 4. Well, this is going to be a 4. Subtract 8 is going to be a negative 4. I found a mistake. This should be a negative 1. This is b squared minus 4 times a times c. The c is a negative 1. Okay, that changes it. So that means this is actually a positive 8 with a positive 4 is positive 12. And the 12 can be factored as 4 times 3, and we can take the square root of the 4 to get a 2. So it's going to be 2 plus or minus a 2 radical 3 divided by 4. If we then reduce all of these even numbers or divide everything by a 2, it's going to be 1 plus or minus 1 radical 3 divided by 2. So that, together with 2, the double root, those will be all of the roots. And now, taking a look at the graph to make sure, zoom 6, so zoom back out, and we've got the 2 we've already checked. Now we can type in these, and it should be somewhere right there where it's crossing and right over here. So trace, put in parentheses, 1 plus the square root of 3 divided by 2, and that should be where it's crossing right over here. Alright. And then check the other one, which is 1 minus the square root of 3 divided by 2, and that should be that x-intercept right there. Perfect. We got all of them.